All right, welcome everybody to class 5 of Data Manipulation and Management in Omaha Data Science Academy. This lecture is about cleaning data using SQL. So, taking the SQL programming language and using its various functions, using its various keywords to be able to take data that's in tables and find duplicates and reformat it the way that you need. Typically in data science projects, you'll have to rearrange your data, or reformat it, or sum or aggregate, or do something to your data to be able to use it in a meaningful way, even if it's well stored within SQL database or SQL tables. So one of the most common things you often do is finding duplicates in data. We'll do some of that. We'll look at strings and clean up different string values. A good example of this is, formats of addresses or in cities and states. They may be in different formats. Maybe one says street, another one says ST. You can use you can use like operators or other string functions to be able to clean those. And using the cast statements to reformat data types. So one of the most common ones you're going to do is to reformat a string. Maybe there's a date that's inside of a string. It's just captured as a string or a character of length 12 or variable character within a field, and it's actually a date. So taking that date and using the cast statement along with string functions to reformat is one of the common things you'll do. And then just being able to start applying a lot of these scalar value functions to different challenges to be able to get the data exactly the way you want. So having it in a database helps. It's often clean, but it is, as you'd see over your career, that's sometimes not always the case. Or maybe you just need to clean it up into some type of format that's more usable for what you're trying to do. So that's going to be what this lecture is all about. All right. So quickly reviewing class 4, so joining and merging data. This is where SQL started to become more conceptual. And as far as being able to bring together multiple tables or multiple data sources into a single query, kind of like your single view or table, there are a number of different ways to do that, whether it's joining two tables from left to right or appending them from top down. And then we revisited subqueries also. I think, as said in the last lecture, pretty well placed because it is a little more conceptual in the sense that once you understand queries, it's easier to understand how a subquery works, how you can bring that together, and that always executes first. And then you could use that outer query to kind of frame it or merge it into another table or summarize it. And then we covered that in a couple of different ways. So you can use that in a select statement. Maybe you're just trying to return a single value from a different field. You can use that in the where statement to be able to, like an in statement, to limit it to a number of values or a number of countries. And then you could use it in the from statement to, like, it's its own little result set or table. Right. So class 5 objectives. I covered this in the first slide, but specifically we'll use SQL operators, wildcards, like functions. You're probably likely, when you're in Python, working with Jonathan on different string wildcards, to be able to do substrings or find certain character values within a string variable. That class will be a good start and good experience. SQL has very similar string operators as Python does. One of the more powerful things that you'll be able to do is the like statement. So the like is really like searching for substrings or searching for certain character strings within a string. I always find SQL really nice and valuable too, especially if you're storing large amount of text or it's just a whole lot of rows with varying values. To be able to say, return me ones that start with certain values or contains, whatever you could possibly want to look for. Maybe it's products and you're looking at, I don't know, anything that contains headphones. You could do like headphones and then it'll return you all those products, assuming it's in the product description, if it's in like a product description. Case statements and logical functions. So case statements, I love them because they're your if then else logic that we've covered in other ones, but they're really useful in cleaning up different cases. So if you have null values, you can assign it a value. If you have certain strings, you can assign them different values or really start to apply business logic to them. Maybe it's just a column with a bunch of A's and F's and D's, but you know what all of those mean. You can use a case statement to say the field is equal to A, then those are all of your A products or whatever grouping, whatever significance it has. You can start to use it to case statements to apply really logic within SQL. And then the logical functions to go with it, add some additional power. So near the end, we will start to clean string, numeric, and date data using functions. And sometimes this includes performing joins, inner, outer, and left. I should have mentioned we'll do that to identify duplicates within the data. I'll show you a couple of ways of doing that outside of just a distinct statement. A couple of ways I often use to try to find what values or rows within SQL have some duplicate values in it. So a little bit different than the primary key. The primary key is that you give it like a certain field or a certain aggregate key. Maybe it's 3 different fields that must always be distinct. In the other columns, the values might not necessarily be distinct. Like in the states or in the cities table, you'll see Omaha and Lincoln with the state of Nebraska. So you'll have 2 different rows that have the state of Nebraska, which is just fine in the database. It's not the key itself, but oftentimes rows that are or columns that are non-key columns will have duplicate values, and then this just finds a way to be able to find some of those, and that can be important in analysis that you're doing for whatever reason. Or maybe you just want a distribution. You just want to see the count of different titles for employees within the business or whatever you might be doing. This lecture will help you do that. All right. So I'm going to first provide a brief overview. So why is it important to clean data, and what does that really mean? Isn't data clean? You'd say, well, if you have it in a table, isn't it clean to start with? But data cleaning is really, what does it mean? It's really, data cleaning is the process of confirming the validity, accuracy, completeness, consistency, and uniformity of data. So that's a lot there. So you have to see, are the values valid? Do you believe that they're being produced accurately? Is it complete? Are there a lot of missing values for whatever reason? Is it consistent? So maybe a consistency is that you have products in 2 different tables. Is it consistent in one of them? Is it consistently updated in one? Is it consistently updated in both? Are they a little bit different? And uniformity of data. So does it match certain values, like you would expect? So there's actually quite a bit that can go into it. And even though data is stored in SQL, sometimes by like a production system, maybe it's Ronnie, you'd probably have a good example of a school system that takes attendance and stores grades and keeps track of everything. Sometimes, for whatever reason, maybe somebody manually enters something into the system that's not so accurate, which frequently happens in business or whenever you can do some type of free text, it can happen. Or maybe it's just some random error that the system has generated itself or some legacy data or something like that. So there are actually really a number of different ways where data can be valid, kind of sometimes valid within a table, but it's not necessarily as accurate or complete as you'd like. Or maybe it's become invalid. Maybe transactions have been added and deleted over time, and some legacy data exists in a different part of the database, and um, it could happen that could be a number of ways that the system's producing data that causes some of these things to kind of get out of whack, which this lecture should help you out with that. So how can you clean the data? So once you identify it, data might not be clean in these tables. Oftentimes it's like with your business knowledge or what you know about the systems or what you know about the data, what you think the values should be, or just your intuition. Like if you know something doesn't look right, you can be able to take a look at it. And maybe it's asking somebody else a question. Maybe it's looking deeper into it. If you have the business knowledge, you may be able to fix it yourself. But doing that along with software tools like SQL, I actually use Tableau a lot to just explore fields and look to see what all the values are, if they seem to be right or consistent. You can load a data set up in Tableau, easily, intuitively explore the fields and the measures, and kind of get your hands on it and really get a feel for what's in the data. So I would use a combination of tools. I sometimes use SQL to kind of narrow it down, or maybe you use the string, maybe use some string operators or some string wildcards to be able to pull certain text out of the different fields and then analyze it. But yeah, it's often your combination of your intuition and what you know. Then it says, what about programming languages? Languages like SQL or Python give you flexibility to run routines for specific projects while keeping costs low. So I have seen where people have built libraries in Python that will help you with data quality. You can see that near the end of this class, a library that does that. But you could also, if you know some of the common issues in a data site source, you can build those into Python also. You could create little functions or routines to be able to clean certain things. And in SQL, we'll see that you can use stored procedures. We'll learn that near the end of the class. Or I commonly like to use views. So when I'm cleaning data from a table, that not necessarily dirty data, but the untransformed data will be in a table, and I'll create a view just the way I want to see the data using different functions and case statements and stuff like that. So I'll save the view on top of that data just for that certain like view that I want. I've cleaned it up for my own purposes. And like now I have that view to say I can query that like a table, and it'll bring me data back exactly the way I expect or I want it to bring me back data. So in Python, there are a number of libraries that can do this. Pandas is really popular just because of the flexibility. It's tabular. You can apply a lot of functions to it. And then there are libraries for data quality or just cleaning it up. And then SQL, you can use text functions, case statements, where clauses, select distinct. We'll see these today. And T-SQL is related to stored procedures. So we'll cover that also in the last class. It'll be part of the more advanced database functionality. But T-SQL is like a transactional SQL that's a little more step-by-step or linear than traditional SQL queries are. But those can be used to help you can do multiple steps and clean up a data set also. So it comes in valuable often. So we'll see that near the end of the class. So that's really the importance of cleaning data and how you can do it, and then what programming languages you can use. And obviously, if it lives in a relational database, you could use SQL to do these things, to apply these functions. All right, so the goals of cleaning data, this lecture follows these goals. So oftentimes you want to remove unwanted observations. You have duplicate observations in the table. Not necessarily, like I said, on the primary key, but whatever part of the data set you're looking at, potentially you're doing a subset and maybe that has duplicates. You can remove those, but it sometimes arises when you combine data sets from multiple places. Maybe it has a one-to-many relationship instead of a one-to-one, so it creates multiple records because of that. If you're scraping data, I've come across this before, you'd end up scraping the same data multiple times, and you consolidate that into one record. Or if you're just receiving data from wherever, like when you're bringing it together, there just may be some challenges to that. So I wouldn't necessarily assume when somebody hands you data that it's not necessarily the cleanest or the way you want it. So you load it into a database table, apply some of these things, and you're off and running. Right. So you can fix structural errors that occur during measurement or data transfer. Measurement may be how the system is producing certain values in the system. Data transfer would be just sometimes data gets lost in translation a little bit if there's multiple steps to create that data set. Maybe one of the steps doesn't include data or change the data in some way. So it can help fix structural errors. That usually takes some type of business knowledge. And then you can handle missing data. So really important if you're doing data science work. If you're doing the second part of Data Science Academy, you'll start to do the mathematics of predictive models and model building and machine learning. A lot of these functions, you won't be able to use the observations or build the models on anything that's missing data. So you could either drop those, often like a where statement, you could do that, where you can impute missing values. So if you find null values, you can put something in that place. Usually that takes some knowledge, or if it's a continuous number, maybe you do an average or a mean, or you put some number in there that makes sense. But especially for handling missing values when you're doing analytics projects, becomes more valuable, which you can do with SQL or Python or any number of language. But yeah, there are other ways to clean the data, but these steps you always want to check these type of steps. Duplicate observations, fixing structural errors, and handling missing values anytime you're looking at a data set, and using it for analysis or your own purpose. All right. So just overall, that's really why cleaning data is important, and some of the things that you want to look for. And the rest of the lecture will follow those goals. So first, we're going to learn about SQL wildcards. So these are used with the SQL-like operator. A wildcard character is used for comparing and or substituting one or more characters in a string. So you have different ways of doing this. So these provide pretty good examples here. So the percent sign is going to represent 0 or more characters. So if you do a BL percent sign, it'll find any string that starts with, or any character string that starts with BL, and then just anything after it. So it'll find BL, black, blue, and blob. This is the one I certainly actually use the most. So you could put this on the front and back of a string, and that's kind of like I'm looking for anything before and anything after this character string, and it can be anywhere in the middle of the string. So that really becomes useful when you're scanning string values within a column for when you're looking for something specific. Trying to think of one that we may have used in city. So perhaps you want to look for, just off the top of my head, maybe you want to look for all cities that contain. You got one, Michael?
Yeah, the ends with Ville, like Ville.
Yeah, you could do Ville. That one it ends in Ville, but you could use a %sign on the front and back, and then it'll look anywhere in between.
Yeah, and if you add it on the front, you can get Pleasantville, Smithville, et cetera, et cetera.
Yeah. I was trying to think of one where I was specifically looking for something in the middle. I guess Ville. I don't know. Anyway, I'll think of a better one over break here, but we use that frequently. We sometimes use an underscore character to represent a single character. So the underscore could be anything. So I'm looking at like the first character is an H. The second character could be anything. And then the third character is a T. So it looks for hot, hat, and hit.
Sorry to take you back one, Jeremy, but you could do new %city. So you can get like New York City, new, Richmond, whatever city, et cetera, et cetera.
Yep. Yeah, it could be, you could use new and then anything in between and then city. So you could do it in two parts. Say, like the example. Say, I know that we have some in our examples too. All right. So if you have these in brackets, it represents any single character within there. So you could put a bunch of characters in the middle with H and T at the end, and it'll find hot, hat, but not hit. So it'll look for the first character H, the last character of T, and the middle is O or A. All right. So the caret sign does the exact opposite. So sometimes think of the caret. It's kind of like the not operator. It'll do like the exact opposite. So it'll find anything that's not O and A. So it'll end up finding hit. And then a dash is a range of characters, which is pretty useful. This would be useful in finding states. So you'd find all the states that start with C, and maybe you have a range of letters here, A through O, and you could return like H. Yeah, so you'd return like Chicago. So what's a city that starts with CA? Not capital. You'd have Columbus in there and so forth. So you can find really like a bunch of different strings that have these characters. And then what's good about that is that once you identify them, then you could limit them, or you could use a string function to replace certain values that meet certain criteria, or you could just use a case statement to redefine them also. So we will see each one of those in this lecture. One important note here is that these are common wildcards within all the relational databases, but they're applied in different ways. So what I mean by that is we will see in MySQL, you'll actually use the regular expression. To use some of these, you'll have to use a regular expression clause in SQL. Whereas you could just, in SQL Server, you could just pretty freely use these. So depending on your database management system is how you can apply these. We'll see an example coming up here using the regular expression keyword in SQL, but the idea is that these are pretty general wildcards for strings that you can use in different ways across different database management systems. They may just come in a little bit of different flavors depending on which dialect you're using. All right. So to build on this example, you can see the example in the class file, the lectures class file, the PowerPoint SQL. That was the one I was talking about at the beginning of class here, where I take the notes out of I take the queries out of the lecture notes, and now I'm putting them in SQL. So I wanted to bring some awareness to that. Plus, I did put a couple of examples in here this weekend. So if we go down to slide 5 or lecture 5, I have a couple of different ways you could use wildcards, whether it's you can use like statements. You can still use the percentages in the like statements or the underscores. But once you start to do the more advanced ones in brackets or carets, you use the regular expression in MySQL. So go ahead and give a couple of those a try. Make sure everybody can use the file and it works for them. I got distracted. My wife brought me down some food while we were talking. Sorry if I stumbled there. I might between the two.
I'd be distracted too.
What we got? Corn dogs and potato tots. That's be feeding me some of what she's feeding the kids. I'll go for it though. Everybody is able to find that file on Google Drive and able to load it up in MySQL Workbench. Go ahead, if it works for you, go ahead and give me the thumbs up once you're able to do that. I got the unicorn thumbs up. My daughter will like that. All my daughters will like that, actually.
My camera's always on this side, and I always have you guys like the video up here because it's on my bigger screen, so I can see better. So always gotta.
Actually, usually doing that too. It seems like I have everything up on the other screen, and I'm like talking here.
Yeah, I don't have the right converter to use both as I would like, so gotta work with what I got.
Yeah, I find it hard to present and talk on the same screen. Like, I just haven't mastered that, I think. As far as like looking at the same screen and presenting at the same time. All right, everybody's able to run it. I think the country one is a good one. So not necessarily like dirty or unclean data, but it's a good example of trying to find countries with AIN in the middle of them. This one might be a good one because I think you have like Bahrain and Spain, and I think you have a couple with that character string in the middle too. Oh, you have Saint, so the AIN is in the middle of the country name. And then this one, a little more obvious. Would be a string of length 1, 2, 3, 4, 5, 6. It could have anything in the first letter, but undin after that. Does that return more than London?
Yeah, there's a London in Canada.
Oh, there's a London, Canada. That's right. That kind of surprised me. Well, maybe it shouldn't. Maybe it's like a British settlement. let's see. So then we have anything that does not start with a B, or is that does start with a BSP. I think the syntax was slightly different here. So this isn't like a caret that's inside of those parentheses. This is one in MySQL that you have to use with a regular expression to tell it that it's the start of the string. And then these you're looking for any country that starts with a B, an S, or a P. And you see you have kind of the whole list of those. And then you have where the second letter is A, B, or C. Here, this is probably a good time to answer these. Ronnie, you had the first question. I kind of held off on until now. Separating PowerPoint.
Michael got it to me, and I got it loaded up and loaded. It was just this file that I was loading the PowerPoint, so I didn't hear exactly where it was. I got it.
Oh,
Thanks,
Michael, yeah, no problem. Michael, you were looking for this SQL file?
He was just helping me get, and he was suggesting those, and we texted back and forth on our phones. So
Yeah, I think I'm good. Appreciate it though.
Yeah.
Oh yeah, that's from a few minutes ago. I keep this text thing open so it's not like 30 minutes down the road. Yeah, already figured it out or anything like that. To give me an opportunity to pause if needed. All right. So everybody has that open. You kind of see how this works with the like expression in MySQL, or you can use regular expression in MySQL. Use some of the more advanced wildcards in this. I'll say one more thing about the regular expression keyword here or clause here in SQL. Is that it has a slightly different syntax than we saw on the previous slide with those wildcards. Just as far, not like the parentheses or anything, but just how you start a string and then their second character would be a dot. And you could also use asterisks to do like multiple characters and stuff like that. But if you want to know more about the regular expressions, I put a link in here about the syntax and how you could use it and the different things that you can do. There's a link that I can open up. I want to open this up in my secondary window. There we go. And specifically how to use this expression. And little videos to go with it and everything. All right, just as an FYI. All right, we will keep moving. All right. We'll go from current slide. All right, we'll toss in a little matrix here to remove the Smiths here, to remove the duplicates. All right, so the purpose here of removing duplicate is to improve the accuracy, consistency, and uniformity of the data by removing identical observations that appear more than one time in a SQL table. So talk about observations. It can be a single column. Think about a single column query that you have. It'd be a single column with a whole bunch of rows. If you use the distinct keyword, you can just get the unique values out of that column. Or we can also talk about removing identical observations as a combination of columns. So maybe you have 3 different columns and you have mostly distinct values, but maybe there's some overlap because there's a certain combination of those 3 columns that appear multiple times. So also using this, so using the distinct or this methodology, you can identify them or reduce the number of distincts that you have. Or it can be basically the entire row also. But when you're getting to the entire row, usually you have a primary key set. So you have end up having distinct rows in the table. So usually more helpful when you have a single column and you're trying to get the unique values, or you have some combination of columns that are not part of that like primary key or distinct the key that the values that uniquely define the rows in your table, which can happen like as we'll see here coming up. Right. So identifying duplicates by aggregation. This is one of my favorite ways of doing it because oftentimes within a single column, I just like to see how it's distributed. So say in this one, it's finding US cities, but the example that I used at the beginning of class, maybe you're finding, people have certain job roles. Maybe it's like an employees table and they have a certain job role. And maybe you want to just summarize it by a column. And you can do a sum of one as a count. So it's going to count, it's going to fill up the rows with ones, and then it's going to do that group by and summarize by each one of those groups. And then if you could use a halving to say, if it appears in more than one row, output the result. Or as you're putting ones in those columns, when you sum it up, if you sum on that group and it's there more than once, return all of those results. So it's going to give you back all of those values in the column that appear more than once in that column. So just using the cities as an example, you'll have Columbus because you have Columbus, Nebraska, and Columbus, Ohio. Actually, don't know if that's the other Columbus that's in there, but there are probably a number of Columbuses. But it has two in the table. Obviously, you have like Kansas City, Missouri, and Kansas City, Kansas. So you see the city twice. You have Arlington, Texas, and Arlington, Virginia. Is that right? I think so. So that appears twice. So you can start to find the duplicates. Springfield, you have Illinois and Massachusetts, and there must be another one somewhere too. But a really good way of summarizing the values in your column. So like I was saying with the job descriptions, if you put ones in all the rows and summarize it by job description, group it by job description, you can possibly, if it's an employees table, you could count the number of employees that are inside of each job description, because those job descriptions will appear more than once if you're just pulling a single column, and then you're counting the number of employees or you're counting those number of records. So kind of dependent on what each one of those rows represent, but either way, if you apply this type of methodology, you can easily see the values in a single column, or possibly you could do this with multiple columns, more than one column, and that would be those combinations of groups that appear more than once in your query. So out of your SQL, the SQL examples, that should be in there that you're able to run. And you can play around with this. So if you have city, I'll give you an example here of where you would do a combination of columns and how that would work. So that's probably, I don't know if we'll find anybody by name and district, because district is like state. Well, let's go for this. So let's go. See if we can find something interesting. Sometimes it leads you to find something interesting in here too. But we're going to group this by city and district, and just everything in the world.city table, and see if we come up with any duplicates. Maybe not, but
Would it be interesting to order by count descending? I guess not with only 3.
What's that, Michael? There's probably a better example.
No. I wasn't sure how many we're going to get back for results, so I just was asking about order by count descending in case there was like a long list.
Yeah, you could order by count descending too. I didn't think that there'd be very many. So there's San Juan and San Juan. Let me see how that works real quick. And once you find those duplicates, you could say select the city where city or name is equal to. So say we identified those, and I'm not exactly sure what those are. So we will go where name is equal to San Juan and district. I'm just typing this real fast and try to keep with our style here. I don't know exactly what this is, but we'll find out using this query. Or let's actually just select the whole record here. San Juan, Argentina, and San Juan, Puerto Rico. That's kind of interesting, I guess. So there's a San Juan in the San Juan district in Argentina. And there's obviously a San Juan in the San Juan district in Puerto Rico. Learned something today. I learn something every day, but that's kind of neat. I had no idea. And yeah, when you're exploring data or cleaning it up, you'll sometimes find those things. You'll find something out unique about the data or the system, or some process or something that generated the data. So you can do this type of thing on any number of tables. All right. So we'll do the next couple slides here, then take a break. Let's see. Let's get back there. All right. Identifying duplicates by key. So find U.S. cities with the same name. So this is kind of like an advanced way of how I just did that last query. So I broke that last one into 2 parts. I did the first part of where the count is greater than 1. So I'm going to apply a subquery here. We're going to get a table that just gives us that original result. Then we're going to use that table and join it by key to find the results in that outer table. So the world.city table to return you all of those results. So I either break it into 2 groups, or I'll do something like this. So you find all of these cities, and then you join it to the city table on name, and then you're selecting star to return all of those results. So it says, give me all the information, the row information where Columbus is 2, Kansas City is 2, Springfield is 3, Richmond is 2, Glendale. And then you see like there's a Glendale, Arizona, Glendale, California, Columbus, Ohio. The other one was Georgia, Arlington, Texas, and Virginia. I have a neat way of doing that. Then after you identify it, it's really a matter of then what do you do with those duplicates? Maybe, like usually it's some amount of discovery, like you find these duplicates and you're like, okay, yeah, I'm good with all of those values. Or do I want to delete them from the table? Usually try not to delete them from the table, but maybe you could delete or update the values or exclude them from your query or handle them in a certain way through a view that you create. Usually it really depends on what you're doing and with the data and what type of analysis that you're doing or report on what you do with these duplicates. But 2 different ways of identifying the counts and duplicates by key. And then you could always use the distinct keyword too. So remove USA cities with the same name. This is usually when you're trying to return like a single list and you aren't concerned about the duplicates. Like you say, I don't really care that Arlington appears here twice. Just give me all of the unique names of cities in the table.
I ran the stuff from the last slide and I keep getting an error code.
Oh, you did? Okay.
Yes.
Let's take a look at it.
And I was looking at it to see.
From the SQL file?
Yeah.
The one with the subquery?
Mm-hmm.
A none column USA in where clause. Oh no, I pasted that in there with the old curly brackets.
Is that okay? I thought
not full. Haven't found a foolproof way yet, but getting closer.
Okay, yeah, that worked. Okay.
Now what's cool is I can just save this and then upload it, and I don't have to worry about messing around with those PowerPoint slides anymore. Just upload it right after class. All right. Yeah, I think that's the last one before we go into functions, but is this usually when you care only about the distinct grouping or the distinct values within a single column and getting those results back? A good one of this would be that employees example is maybe you don't care if customer service representative comes up 30 times. You just want to do a distinct keyword and you're saying, just give me all of the unique titles. Just give me all the different titles within the business without repeating any 30 times or 10 times. I just want to know all of them that exist. And that would be a good use of the distinct keyword. Hopefully that. I think I did put, maybe I didn't put that query. I need to put that query in here too. But if everyone's good, we could call that a break and then we'll come back and apply some functions to strings and dates and numerical values and nulls and things like that. That type of things, like converting data types or manipulating them in some way, the way you need, or filling in null values is one, like at the beginning of classes, that's important for modeling. Or maybe you just want to include them in like an other grouping or something that's frequently or missing or not applicable. So reclassifying those or filling in the values. Does everybody say take like a 15-minute break?
Mm-hmm.
I've been kind of picking away at this thing. I'll take it off camera and finish it here.
All right, I'll see you guys in 15.
All right, see you in 15. Okay. I think that worked out okay. So I did click on the wrong webcast here. This was the one I set up for Wednesday, but I was able to change the names and everything. So I think
cool.
it ends up okay.
Good.
Just check the link. So if you go to YouTube, it says Class 5. And I was trying to figure this out for Facebook. I think it's doing the same. I think it's doing the same. Yeah. Okay. Yeah, then now it has class. I think it's doing the same. Yeah. Okay. Yeah, then now it has. Shut that off. I hear my echo. my voice repeating or yelling back at me. But it's good. I went out to Facebook and now it has the same title, so it's all on the same page. It worked out. So I was gonna ask Michael. I saw that you're on the roster to teach classes. Are you eventually thinking of doing that? Teaching some Data Science Academy classes?
I'm open to it, particularly if it's a backup role. I don't know that I don't know if that I'm primary for any of them. But we'll see what happens.
Yeah, since you'll be a grand expert or a master expert after this class in SQL.
Through you, yes.
Teach them like sensei and student. But no, I like teaching these at night. I'm glad I'm done with classes, with Creighton classes. Or else it'd really be a lot. And I'm in between sports coaching too, so that kind of works out.
That would definitely help. Yes, I know how crazy that could be.
Yeah. And
we're at the point now with kids where they drive themselves, so it's a lot easier just to go to their events.
Yeah. No, yeah, there's surprisingly, there's I don't know if I was telling anybody, I just stepped into the role. They needed a junior high basketball coach, and I guess nobody wanted to do it. Or at least that's what they told me. Get me to do it. I'm like, well, the girls have to have a basketball team.
That's right. It's that pressure. I don't want my kids to miss out, so.
Yeah. Well, I'm sure they were saying that the PE teacher would have stepped in or something, but she already coaches like 2 other basketball teams. So I don't think they would have gone without, but yeah, it's a continuation. A lot of the girls who play soccer, they play all the sports, so I know most of them anyway. My daughter wasn't going to play basketball, but since Dad's coaching, give it a try.
Yeah. Okay, Dad.
She not much of a fan, but she kind of likes being part of a team. Being part of a team's good. And we have fun while we're playing.
And I think that's part of what's neat about it. Yeah.
I mean, it's competitive, but it's not like end of the world. It's not like Husker football or anything like that. You lose, you're about to get fired or something. But that's the difference between making $5 million a year and doing it for free. Yeah. Although it doesn't always keep parents from complaining, but you learn how to handle that too. Just take it as constructive feedback, even if it's not. Get somebody. But no, as long as usually though, as long as you're pretty respectful and good listener, like I am, people are usually pretty respectful.
Oh, it'll be good.
Listen to people with an open mind.
Definitely.
Try to hear their concerns and address them.
Yeah.
But parents, they can get crazy at these things nowadays, especially if it's like tournament time or something kind of ramps up.
Yeah, get a little too wrapped up in it.
Yeah. Had a bad day or something and bring it to the sporting event.
Right. Their kid winning is going to make all the difference.
Yeah, or they start to get oftentimes it's between parents or something. Start to get a little mouthy. I never noticed it when I was a kid that much, but maybe that's because I was playing the game and not paying attention to it. I don't know. I think it happens a little more now than it used to, especially with referees. Hard to be a referee nowadays.
Yes.
Almost everybody shouts at you on the sideline, tries to blame it on you. But that's what they do at like all the sporting events too. They try to blame something on the referees. I'm sure there aren't that many referees who are like trying to intentionally like,
the biggest odds for a
it's not like
little
Nebraska.
kids.
It's not like Nebraska needs the refs to be against them to lose the game or anything. Right. But there are people on the listening to the post game. There are people like, oh, if it wasn't for the refs, we'd have like 5 wins. Like, nah, probably not. Probably not, but however you rationalize it.
Right. Whatever you need to believe.
All right. We ready to roll? We could probably get through this and then have plenty of time to do some work afterwards. So the functions part's a little heavy duty. We spend a little bit more time running these examples, but it'll be good. We take those mostly scalar functions instead of aggregate functions, and now we're really starting to apply them and see the results. So we'll get after it. Well, I like your Husker Cup, Ronnie. So Ronnie is a Husker fan.
I have to use my husband's, soup bowl and plate when I need to eat on the run. And I'm not really allowed to have much Hawkeye stuff in a Nebraska home, but it's boxed up in a TV box in the garage. But my senior pictures were taken with my Hawkeye gear, so I'm a Hawkeye.
Yeah.
But it's not hard to use for good coaching.
Yeah, for a lot of years, like I have a lot of family from Iowa too, and for a lot of years, I never was a person to rub it in or anything how good the Huskers were, but they'd ask me every year and then be like, I hate those guys. But now they really rub it in. They try to give me like Iowa Hawkeye white elephant gifts and stuff like that. I think that's really funny. And I pretend like I don't care, so it like kind of ruins it for them, but it actually doesn't really bother me that much. It's a game. All right, let's as much as I'd like to talk about football all night, we'll go ahead and do lecture here. Yeah, so scalar functions. So really putting these into practice now. So we saw this one, must have been the second lecture where we're talking about different scalar functions. We talked about aggregate functions where you summarize values over an entire group or an entire table. These are applying these to each individual value within a column down all of the rows. So we have string functions. Concat's one of the most important ones. So concatenating 2 different strings to create a new one, whether you do that in Excel or SQL. Oftentimes you can use concat to kind of create a primary key, a concatenated primary key. So instead of using 3 fields, you can concatenate and create it into one. Or just for whatever reason, maybe you're putting city to state together and first, middle, and last name together. You're concatenating those. Length is valuable when you're doing like a substring. You want to know the length of the string. and maybe you're searching like part of the string or 3 values in from the left or the right, you can use a left or a right. You can replace substrings using wildcards. That's another place where you can use those. Trim is removing leading or trailing blanks.
I just want to pop in. Do you want to be sharing a screen right now?
Yes.
Okay. There's no screen being shared.
I just went after it. All right. I've done that more than once.
I was like, I don't know if we're going off.
I'm talking to myself. It's a little bit easier even when I'm talking to be able to see what I'm talking about, right? All right. So I'm going to go full screen, and I'm actually going to change back to that banner. We know what class we're doing. Yeah, so just talking about string functions, you can do replace using wildcards, substring, to get not just the left or the rightmost characters, but anything in between. Trim does leading and trailing blanks, especially happens a lot in variable character fields where maybe it's bigger than the actual string and then it's just loaded into that column with a bunch of blanks. You can trim those away. And then there are a number of ways you can format strings, especially when you have dates. You can use the string or the format to reformat that date string into something else. All right, so control flow functions, we know the case statement. If and if null are similar, you can just use these as functions instead of a multiple step if when. So you can use an if or an if null as if the value is null, which can be really valuable when you're looking for null values in a column and you just want to identify them and then fill them with something. And we'll see we have 2 parameters on this one. You'll have the field, and if it's null, what value you want to fill it in with. Date and time functions. So a number of ways you can manipulate dates to get what you need. Current date is a function that returns the current date time of today. So if we were to do this right now, it would be 11/1/2021, and I think it's in year, month, day format. So it'd be 2021 11/1, and then you'd have the time, which would be I think it returns military time, so 1929, depending on what time zone you have it set on also. Day, month, year is valuable for extracting the date, month, the year out of a date or date time. It might be valuable to just get the year and say we want everything in the table where the year is greater than 2020. Date add, you can add a number of days or subtract a number of days from your current value. You can increment or decrement. And now similar to current date, you can use the now function also. Right. Comparison functions, coalesce. So coalesce you can actually have as many columns as you want as parameters. You'll take the first column that does not have a null value. So say you want, maybe there are different product categories and you're looking through 3 different fields for those products. Maybe it's one type is Bluetooth. You have a Bluetooth column, Bluetooth description. You have a wireless description, and you have cell phone cases. And maybe you want to look through those 3 to see if there are any values. So maybe from left to right, you want to return the first one that has a value. So we'll see other probably better descriptions or examples than that. But that's the idea behind coalesce, is that you have multiple fields that you can use, and it'll return the first value across the row, across those columns that aren't null. That's not null. And there's definitely an example where you'll see this. So American math functions, you can format your number in different types. So integers, decimals, floats, so forth. You can do the ceiling or the floor. round and truncate, so you can do different things with decimals. And data types is one of the most important. Probably the one that you'll use most is casting a string to a different type. Whether sometimes numbers are stored as strings or dates are stored as strings, but you can do any number of casts that are, as long as it's valid. So you can't, or you could even cast an integer or something as a string. So you can take a number and make it a string, and maybe you want to search for a decimal point in the string or whatever. But as long as the transformation is valid. So if you have a string that says Jeremy and you're trying to cast that as an integer, you won't be able to do it because it's a string that doesn't convert to an integer. So as long as the data types are congruent after you use a cast function, you're able to change it from one type to another. And we'll see examples of this also. But very valuable functions in defining your data types and changing them, manipulating numbers, finding null values, and a bunch of string and date and time functions. We'll cover that the rest of this lecture. All right, numeric and comparison functions. So you can change the format of a number to the number of digits rounded to d decimal places. And you can you can see this is largely a display format. So it doesn't necessarily change the underlying data type, but when you're doing a query, it brings back a number that looks like this. So the difference here is that a display format or function, or this format function, it doesn't change the underlying data. It just changes how you display a number. So take, for example, you have this long decimal and you want to apply this format number 3 to it. And you can look up some of the numeric functions and which numbers are which formats. But this number 3 formats the display output in this manner with the comma and the decimal places. All right, so cast, we talked a lot about that. You can convert a value of any type into a specified data type. And like I said, as long as that data type will conform to that other data type. So this one works. So you can cast 150 as an unsigned integer. An unsigned integer is one that isn't negative. It's always positive. But if you were to cast a negative there as unsigned, then it wouldn't work because the number wouldn't conform to the unsigned integer data type. You can use if null. Returns a specified value if the expression is null. This is, like I said, really good in finding null values. This just uses the value itself, if null. So this is automatically null. And if not, return 500. So this function right here just compares these two values. But if you could use a column in here. You could say if null product, and then you could return a string here. You could say NA. So it'd fill in all values where the product is null, or it doesn't have a description. And then it could return something like NA. So not available or not applicable, or however you'd want to do that. Very valuable in what, like we talked about earlier, the imputation. If you find one, either putting some type of value in there, a number, or something similar. Right. Is null returns 1 or 0, depending on whether an expression is null, especially probably valuable in either a where statement where you're just want to return null values if it's null. And this could be a column or a case statement. So you'd say, if this column is null, you put a column in here instead of the null value. And if it's equal to 1, then set the result. So really good in like logic type statements or where type statements, the comparison type statements. Then coalesce, here's the example. It's a function returns the first non-null value in a list. So out of a bunch of different values, you go from left to right. And you see the first one is null, the second is W3 schools. Finds the W3 schools and returns these. So think about this. These are all values that I put in here to illustrate the example. But it'd be the same way if these were all columns. So if you had 4 different columns, it would look at the first column, the second column, the third column, and fourth column. And then it'd return the first value with the null value. So it's comparison. It's doing a bunch of comparisons on the values since they're value scalar functions in SQL. It's doing that across the rows on different values. These numbers and letters in here just to kind of illustrate like when it evaluates those numbers in a column in a given row, what the numbers would return. So oftentimes, more than likely, you wouldn't just put a number in here. You'd put different columns in there also. All right. So we'll see examples of this. First example, let's do numeric functions. So fill in and convert GNP old values in world.country. So in the world.country table, this field GNP old, it has a number of I think this is in millions of their gross national product for the country. And as you can see, it's actually missing a bunch of those. So what we do in this one is we'll first round the GNP old. So this one, yeah. So we round it to 0 as unsigned as GNP old 2. And it gives us unsigned values that are rounded to 0. And then we fill it in with the second query. We fill these null values in with zeros. Let's go ahead and give this a try in the code. All right. I should have these in here. Identify duplicates. There we go. So out of slide 13, we have this one that rounds all the existing values that are in that field at 0. Because we saw in our example, these actually had decimals after them. So it just rounds it to the nearest whole number. And then it converts it. Once it does, it converts it to unsigned. So if we were to take out this part, the convert, it should actually still leave a decimal. Oh, it didn't because it rounded to 0 anyway. So it rounded to 0 decimal places. And this one just changes the data type. It doesn't really do anything else. And then with the other example, it replaces all the null values with 0. Good on how to use numeric functions. And so with coalesce, how this worked, it looked at the first value and it would keep it as long as it's null, but it would put 0 there if this GNP old is a null value. So it evaluates it from left to right. So really valuable if if you have a first call, like a first, second, or third option, like check this column, then check the second column, and then if all else fails, you could enter your own value in there. NA. They're really valuable for multiple part coalesces or multiple field, or somewhat kind of like an if-then statement also. but it checks multiple fields and by default, like a case statement, checks multiple fields and then defaults on the last one. Now, here's a good question. What if you have null for all of them? I believe it just will return the last value, whether it's null or not. Yeah, it just returns null. It'll go null, null, and the last one's null. But if I did A and null, it'd return the A. Oops. Did I run the right query there? Yeah, there we go. Returns A because you get null, null, A, and null. But if you have all nulls, it'll just return null at the end. But just playing around with these functions just to show how they work. All right. We'll keep moving. If everybody's good with that. All right. So string formatting functions. So a number of these that are you're able to put new strings together. Like I said, one of the common is first name, middle name, and last name. And then if these were fields, they would work their way all the way down the table for each row at a time. In string would return an integer, which indicates the position of the first occurrence of the substring. So valuable, if you're trying to find a substring within a bunch of different strings, and usually you would say something like, if in string of a field is greater than 0. If it's greater than 0, then you know you found like a substring. If it's not, you didn't find the substring in there. Yeah, so really valuable for finding substrings and then what position they start at. Also useful if you're using left, if you're using the left function on strings. So you would start, say I just wanted like the last part of this, the ST, or I guess the ST string. You would say, we start at, we would do like a substring 5 to 13 to get this part of it. Just that part that starts with ST and then get the rest of it. Or you could also use the length function along with it too to get this from 5 to the end of the string. Right. So a number of ways you can manipulate strings there and get the length back depending on what you find. So trim, said it a couple times. So it removes all the prefixes or suffixes from a given string. You can specify in MySQL, you can specify leading or trailing from the text. If you don't want to remove both, because that's what it does by default, you can put the leading or trailing keywords in there. So here it will train, you actually define the leading here. So it takes out this part. It is the text. So the trim by default does blanks, but you can see here you can do a leading or trailing and then define your characters, and you can trim those out of it. So say for whatever reason they're just extra characters added on to a string and you know what those characters are. Maybe you want to move ing from the end of all of them, or you want to remove text from it because it was just placed on all of these for some reason. So you could do trim the trailing text from leading text, and you would get this one. And maybe it's on all the fields. You could use that and just trim away all of the characters you don't need. right? Replace is valuable because you can replace all of the occurrences of a substring within a string. So for this example, you have W3 resource. That's your starting string, or maybe your starting field. And then if you find UR within that string, just replace it with an R. And you can see you replace this with an R. So really valuable if you're looking up something like you want to replace street with ST. You could do that using this type of function. So it says maybe my address 6536 North 32nd Street, and street is spelled out. You could do street here and then ST. So that when street is found, it replaces it with the abbreviation. All right. So lowercase and uppercase strings, you can convert them to all lower uppercase. It's can occasionally be useful as sometimes text is entered in all caps or something. You can just change that so it displays differently. You can change between the cases, or maybe for some reason you just want them all in lowercase. Length of a string returns the length of the string. So useful in telling the different lengths. If a string doesn't exist, it will return a 0. So that's a way to check if its string of size is 0 as opposed to a null. Because sometimes these can be blank, but it could actually be a blank instead of a null. And I believe if you apply this to null, let's check this out. If you do length of null, just do a quick select. And interestingly enough, you can do a query without specifying a table as long as you can return a result. Yeah, so if you do, so the difference between a null and a blank string is that if you do the length of a null, the string doesn't exist, so it can't return you a number. But if you were to do a blank string, return 0. Yep. So also potentially a good way if you use the length function to tell whether you have null values in a column or you just have blank string values, which can then sometimes be two different things. Kind of like the non-existence of a value versus it exists, it's just blank, or no information was entered for some reason. All right. And then substring is one. You can extract some of the characters from a string. So it starts with a string or a field. You start at the first character, and then you get the next 3 characters. So it starts at character number 1, and then it counts from the first one, 1, 2, 3, to return SQL. So you could start farther into this. So you could do substring 5, 3. So it would start at 5 and then return the 3 characters, which would return tut. So really valuable if a left or a right doesn't work, if you can't return the left 3 or the right 3, if you're trying to find some type of string in between the two. And if it's not found, I believe that it returns 0. So if we put this here, well, substring, it doesn't matter because, the substring just starts from a character and then returns the next whatever characters. Now, if you did something that was out of bounds, to say start at character 99 and return me 3, I'm pretty sure this is going to give you an out of bounds error. Oh no, then here it doesn't actually do anything. it just goes out 99 and tries to return you 3 and it returns a blank. I think in some of the database management systems like or SQL Server, they'll actually return you an error. It'll say like value out of bounds or like some type of out of bounds, like length out of bounds error, but it doesn't do that in MySQL. All right. So let's apply these string functions. I do a number of them. I put a lot in this case statement just to show different examples of what you can do. And then what this is doing is convert USA, city, and state names to city, comma, zip in world, or city, comma, state in the world.city table. So that is what you'll have, the state abbreviation, and then you'll use the concatenate function to do the city.state. So really this is all now about either label using a number of string functions to create your labels, or to use the concatenate function to put city and state together into a city-state full type format, really getting it into the format that you want it to be in for whatever your purpose may be. So I have that here. Then you can see that query. So sometimes I like to I'll put a space in that concatenate, format it a little bit nicer. So now you have the comma and then the space and then the state afterwards. You can actually do something kind of neat here too. So instead of district, you could put this case statement in here as the last parameter. So you basically think of this case statement as another field that you created. I will actually be a little bit fortunate if this runs without a syntax error on the first time. And it did. So now instead we use that case statement. It's like the third field in the concatenate. This is a little bit easier to see if I do this. Try to give that a tab. So this becomes my third field, like with the abbreviations. And now we have an abbreviated city-state. So you can really see, you can start putting within functions, you can start putting different types of strings and columns and then like derived columns. You have a lot of flexibility now with what you're putting together with these functions and really how you can manipulate this data and create exactly what you need out of it. And moving along, everybody good so far? Running the examples makes sense? Good? Okay. Just checking in. All right. So actually, nearing the end of this, I'll have a little bit of time to work on exercises, which is going as planned. Right. Date formatting functions. We covered these a little bit. The cur date actually returns just the date. It doesn't return the date time, just the date part of it, but it does return it in year, month, date format. So if you select current date, that current date will be replaced by kind of that year, month, date format with dashes in it. So particularly important to pay attention to this date format. This is like the preferred MySQL date format. So if you're entering dates like this and you convert the date type, MySQL very much knows this date type and it's just more compatible with all of its functions and its date conversions and everything. So just something to note. You can get current timestamp. That's the one that I was talking about earlier. It returned this function, returns the date plus the military time in hours, minutes, seconds format. So if you ran it right now, it would be the 2021 11/1 at, it's almost 8 o'clock, so 20:00:00. And then if you have a date time format, you can use an hour on it, so you can return the current hour. So similar to those year, month, dates that we saw that you could use on date, which you could also use on this timestamp, you can use an hour function now that you have a time that goes with it. So you have the date time format, then you can apply the hour function of it to get hour 13. So maybe really valuable if, I used to work in call center environment. If you wanted to see on a certain day out of the database, what type of call volumes did you have at hour 13? So you could use this function, say where hours 13, be able to get all your data for that. Right. Date difference returns the number of days between two dates or date times. This is widely useful, especially in either this example, how many days was it from today? Or maybe you could also use two different fields and say, what's the difference between your start time and your end time in your database? And then it give you those number of days. So usually you want to go your biggest number and then your smallest date going first and second. But if you do it the other way around, it will just give you the negative. It will return you the negative number. It just goes first minus second. So something to keep in mind. Day of week, also useful if you want to do like a day of week analysis in the call center. What it's for one starting on Sunday. So it starts on the Sunday of each week, 7 through Saturday. And you could define a date there. Or you could just put labels on these, say do a case statement. You say case if day of the week, current date, or some date is equal to 2, then give it the label Monday as a string. Maybe, maybe you're importing that into Tableau, and instead of these day of the week numbers or dates, you want to derive a field that's Monday, Tuesday, Wednesday, Thursday, and Friday. So you could do that there. You could do that here in the database with that function. Day, month, and year, already talked about that. So out of a given date time, or out of a given date format, date string, you can return the day is 15, the month is 5, years 2008. And just to once again note, in MySQL recognizes this format as in a date. So that's why you can apply date, month, a year inside of these strings. If you were to put dashes there in MySQL, it would not be able to recognize it, which is kind of unique to MySQL because other databases, they often recognize different data types, but in MySQL, it does not do that. So just as we go through the class, just pointing out the differences between different database systems. And you're only at Google, all the database systems have these day, month, and year functions. They just may apply them differently or expect a different type of date format or something to use them. So just something to keep in mind. And then the current date returns the current date. Oh, we already covered that one, so we are good. All right. So here's an example of the date function. Get the number of years since each country's independence. So here's where you could start converting these dates into years and then taking the difference. So the neat thing about is it's sometimes important to note what the return type is on these. So let's go down to this one. say if you get the year of the current date, that will be 2021. And you have the independence year, which is already an integer. And then once you take, since the year of current date, since the year returns an integer, you can do an integer minus integer to get the number of years. So let's see what happens here. Oh no, it returned that last one. I've noticed one occasionally, some of these results kind of stick. Or I run this part of it and it still runs the last query. So what I do is just drop it into a new window. And then you can, for the nulls, it'll return you a 0 because it doesn't know what to compare. But you'll see you get the current year minus the independence year, which is they're both integers. So 2021 minus 2000 or 1919 is 102. Some of these were a long time ago, 700 years, when China would probably be about the highest. Let's go ahead and order these by year index. Ordered by we want descending. So we can put the keyword descending there to order from highest to lowest instead of lowest to highest. Yeah, China, it has 3,544 years ago. So since it's BC, they label it as the year minus 1523. Interesting, Ethiopia is pretty close. Denmark, Sweden, France, United Kingdom. See, we are actually, as far as independence, we're a little farther ways up the list. I wouldn't have expected that. How I feel like it seems like 245 years would be one of the newer countries in world history, and I guess compared to a lot of these other countries, it would European, some of the European and Far Eastern, but still south, like these countries in South America. You go through it. It's kind of interesting. I guess a lot of these countries are occupied by other countries at some point in time. It's probably why. With the most recent being the Netherlands, Antilles. Oh, also the time of the night, same time each night where the cat comes to join me. How do you find me every night at this time? Somebody let you down here? All right. So yeah, state functions, important to note, like I said, sometimes what type of number, what the return type is on the function. And if you know that's an integer, you could use another integer, subtract it, and get that year difference. And I believe on one of these slides, there's a great big list of functions. So there's, in the bottom of these, I've tried to list them over time as either your numeric functions. I don't know if I have one for date functions placed in here, but you can go get string functions. The W3 Schools is really good for that. W3 resource. But really any Google search was saying something like MySQL functions. Maybe you want date functions. You can go to the reference manual, which is really usually kind of heavy duty as far as being extensive and seeing everything there is to offer. And these aren't too bad. Sometimes they get a little bit of technical read, but if that's the case, something like W3 Schools or Tutorial Spot's really good too. They usually provide pretty good examples in more of an example format as opposed to syntax format. I actually use that and appreciate that sometimes instead of kind of decoding the code that they've put in there, the syntax, which is like the form of the language. So that like function in numerical, current time plus 0, current time plus 12, what all the examples look like. It's kind of nice to see the examples to see like the impact or seeing exactly what it does, or if you subtract values from current time, like what does that do also? Really, I kind of like both the documentation and the examples. It kind of puts the two together. Be able to see it a little bit easier. All right. So that was date functions. And then just a last slide, not exactly errors or cleaning up data. This is more about common syntax errors. So syntax errors, like we see, is I'm sure as you've gone through writing queries, you have like you've got error messages or like little things in the syntax. The common syntax errors that you'll find is just a spelling of the table or column or names, just like you misspelled a table or a column or some type of comparison value. Say like you're comparing one string to another, you're using a like statement. Maybe you mistype something. Your quotes, your single, your double, and your backticks. So your single quotes are, and these actually also vary between database management systems too. But in MySQL, you use the single quotes for strings. You use the backticks for kind of like those reserved field names like name or date or something like that. It allows MySQL to know that you're talking about the field instead of the keyword in SQL. Right, so data types, if you're doing integer as varchar, like I guess that's really just mixing up your data types or data types that don't conform with each other. That's really common, especially if you're converting to like a string to a date or a string to integer. It may go down the table and eventually find something that's not an integer, and then it will give you an error. The order of SQL clauses. So just that order, the select from your group bys, your where statements, making sure all those are in the right order. And after a while, that just becomes kind of second nature. But even at that, like it's a little bit easy to put like an order by out of order or something like that, or you're writing a query and it gets mixed up. Joining on the wrong column. So it's easy if these are two different names, like if it's the same value, or they have the columns have the same value, but say this is pet name in here and this would be Facebook name or something, and you were to join on the wrong columns. And then usually it wouldn't return any results because it wouldn't find anything, or it'd return something really strange. And then over filtering in the where clause, which would just be filtering out too many results. Usually just more than you would expect or less than you would expect. Or filtering out everything. Maybe you mistype something and you don't return any results, which is very common. I was doing that today, actually. Have to think about what I I was working on, let's see, what was I working on? I was working on some billing codes, and I was typing in one that I was pretty sure would give me results, but it didn't give me any results. So I had to go back and check what the billing code was on certain procedure. And come to find out, I had a typo in mine. So common syntax error in overfiltering, or just entering a value that you expect to return you a lot, but ends up not doing so. Let's see. And this has a source too, a good guide for these things. Let's go ahead and take a look at that. This whole thing was SQL for non-technical people. I use this and referred to this in different slides. This one's just a really good one. Quick one from start to finish with those visual values. Just if you ever need a refresher. And I think this is near the end of this. Common syntax errors. Capitalization. Single quotes, backticks, joining on the wrong column. Now these are illustrated, so be good to take a look at these, and they give you some illustrated examples of these common errors. All right, I actually left about 20 minutes or so. I stick around for 20 for the project. And this project is about cleaning up some values. So this table that I loaded, it is an example of a table that's not loaded in usually a format that you would typically use. Has some NA values to create and then derive a text field in this from the table that has this name. So this would be kind of like deriving a key, a game, console, company, and genre. Then for 1 to 10, fill in the game and genre columns with relevant information. So I think this is the top rank ones, and look at the difference between today and the date the pre-order list was last published. So to help you out with this, I would point you to the class project database. And I have the USA pre-order table already loaded. So you can see it has games in it. It has a top 10 down here without any game names or anything. But notice I put some of these here with commas in them or missing commas. And really the exercise is just to identify like substrings within these and calculate date differences and things like that. I've also created a view to do this. This USA view pre-order. Like I said, when I clean up a table, I like to leave the underlying data structure alone. But what you can do with a view, if it exists, you can right click on it. You could do, let's do the create statement. Oh, maybe not. In the SQL editor. Trying to get the code out of this one. Okay. Oh no, here it is. So this is what it actually looks like underneath. And don't worry about it because in the milestone class 5 cleaning data, I have the exercises results for the exercises here if you want to run these and take a look. Or this last 15 to 20 minutes is up to you if whatever we want to work on. I'm all ears. Or anything you'd like to cover again from tonight's lecture. I feel like sometimes I pack a lot into these sometimes. So let me know.
It always goes back to the I take it, absorb it, and then once I kind of start messing around,
Yep.
questions start coming up.
This example might help because I try to put a lot in here too, and I do a big case statement here in relabeling. There's a date difference. Today, I feel like maybe I have some exercises here for this too somewhere. Maybe. Class 5 examples. You have these class 5 examples also. These should help. This is in the examples folder on Google Drive. There's one that's called class 5 examples of formatting. These will give you some additional examples also. So case statement. So this is kind of like one Michael talked about earlier. He's using the percentages on each side and finding of. So that would find District of Columbia and then put it in the East Coast region. Identifying duplicates. This one gives a pretty good example. The class 5 examples. Say, Michael, by the end of the night here, I feel like you start to fall out of range of the camera. Still there? Hey, it starts to slump, and then I'm like,
he's probably muted. Hey, I have a couple questions
down there somewhere.
Yeah, I was muted and sitting down. Go ahead.
I'm like, Michael slumps like a little bit. It does get late in the night, so it's like, bowling over. I wouldn't blame you though.
But questions I had are probably more broad.
No, go for it.
I mean, I appreciate all the examples and referencing back, but like, I have this, 4 different tables that I want to try to piece together, from advisement attendance to the multiple Fs report to, a frequent flyer list that our security guards, are always asking us to identify, to kids who are off track by 10 credits, and just trying to bring all that together to best have intervention supports. And so as much as I want to try to practice, and do the project, my big questions are this MySQL environment that you had us download and install.
Yeah.
I'm comparing it to Tableau and how it was a trial, and I know I can't put district data out on a cloud and play around with it. I would like to build my own SQL database, if that's what I'm calling it, or schema, however, and bring in, 4 files of data that I've downloaded with various queries out of Infinite Campus, our district database, to think I could practice some of these skills you've been teaching us. But my big question, though, is just making sure I understand the whole big picture of this software that you have us using. Can I do that with this software and not worry about the data going somewhere?
Oh, I
in a-
wouldn't do it on this server, but what I used to do in every class before this, I'd have everybody install MySQL server on whatever computer they were using. Like the last time you took this class, Ronnie, that's what we did.
Right, but I'd have a
Um,
different laptop because my other one failed, so I'd have to, do that installation. But that's really where my brain's going, just because as much as I want to practice and figure it out here, I'd like to do it with data that I could really validate true results and know what
Yep, I still have those. I still have those instructions on how to do that on your own computer. I could give those to you. I'd be more than happy to help.
Yeah,
you
even
set
if you
it
just
up.
shared them in our Slack, spot or whatever.
Yeah.
But that's what I needed to first just be comfortable and make sure I was being able to do it in an isolated location where it's not, I'm not worrying
Yeah.
about privacy issues and all of those things and,
Yep.
confidential data.
Yep, you would not want to do that here, although I give you your own schemas to do that. It's just like more of a public place that you'd probably get in trouble from the information security people or whoever's like the custodians of those for putting them on a server like this, right?
Yeah.
Then let's see here. Let me drop you one of these. Here's the SQL Server install that I used from last time.
And this is all downloadable freeware. I'm not breaking any copyright stuff or anything like that either, right?
Nope. I think that you can even use this for, I guess you would call it it's not quite a commercial use, right, Ronnie?
Right.
It's like
right.
educational.
Educational, yeah. I'm just.
You're an educational institution too.
Yeah, and I'm trying to play around and access without, getting a real. It's more of a sandbox thing, but it just for proof of validity, reliability, whatever. Working with some data.
Usually, it's with these things. It's usually as long as you aren't using it for commercial purposes.
Right. I'm not making money on it.
Business, like you can use these for free. MySQL, I think MySQL used to be why the whole community loved it is that it used to be open source.
Right, and that's what I was wondering that, but again, I just
everybody
dangerous enough or novice enough to be dangerous, but
MySQL Oracle bought MySQL a few years ago, and standard. You may. I think that you could. Okay, so annual subscription for MySQL standard is $2,000 a year. I'm sure you don't want to do that.
Well, my district has that. I mean, I just like Tableau. I can go beg, for a license that's probably sitting around as a district entity that has probably installed on some,
free open source software, universal. I use it for this class because it's you can specifically use it, MySQL, for learning purposes. Here, and just download it on your computer. That's not a problem. Oh, I want somebody to give me a simple summary here instead of reading through legal.
And of course, I got to get administrative rights to do this, so I can't, do it without that. But
Well, it does say, is it legal so someone on Stack Overflow, which is good for answering questions. Is it legal to use MySQL in commercial environment? So release your project. Okay. So I think you're good. That's what the whole community likes, and I think they kept it that way. Is largely you can use it as long as you like don't modify the database and like try to resell it yourself or something. So all that other stuff that you pay for is like support and extra features. But if you install this database, I'm sure it'd probably be more than enough for what you're trying to do.
Right.
It'd work just fine, and you'd be familiar with it and have all these code examples and be able to import and everything. Now the next lecture will be good because we'll start to talk about how to design a database. And then when you have multiple tables, the relationships between them and doing a relational diagram. So once you start
that's exactly what I want to almost lay out. I mean, I got it in my head, but I'm like every day I want to add something to it, but I need to have it that just so I can communicate it with the people up the chain in my organization. But
no, if you keep adding things, it could eventually look like a spider web. Be a spider web of data, which is okay. At least you have it in. You can query all of it anyway. But yeah, it sounds like you would do the data sources that you have. You probably import them and find common keys or relationships.
Yep.
We can draw that out. We can draw that out on Wednesday.
Well, I will see what I can do between now and then because it's just I need to show them the value of this just at a position of my level, but then to get it into our teacher and our students, just a skill set to be able to, do better with data in education.
Yeah. How it'd be cool to show people the way, show what the cool stuff you can do with data. Nate talked about teaching this class to high schoolers.
Right.
Some cool examples. Also, we haven't got COVID set one of them away to the side. We were going to do one at Highlander Academy. While I was doing consulting, but COVID kind of brought it to the stop, and the not enough attendance. But we'll see once we get past this hopefully last wave.
Right.
Of it.
Sorry,
but it'd be cool. I would have loved I took a programming class in high school and it's Fortran, but I would have rather learned SQL really. I mean, it's different than regular programming language, but it's more I like working with data. I find programming's interesting, but I like working with data, getting your hands on it and understanding it. And I like you talked about baseball cards. I'm like a baseball card guy.
Right.
Try to find interesting relationships or nuggets in the data and use the language to do it or relationships. I would have rather learned that than for programming in Fortran.
Well, just the application of, working with the data, I guess. I mean, not that learning the language isn't, but it's, there's only so many and else and all that, but then to put it in, and actually manipulate data with those statements.
Yeah, to do the things that you can do. And it's really practical. Like it's kind of SQL's, I think, is like a relatively lightweight programming language.
Right.
Compared to Python. Because Python, you have a bunch of the syntax and data structures and then conditional statements, and then you have like all the libraries on top of it, and different programming styles or stuff like that. There's quite a bit to unpack.
Mm-hmm.
With this, it fits pretty well, and you can get up and running almost after lecture 2, probably.
Mm-hmm.
Say more. I have any questions?
I don't think so, not tonight. But we'll get working on that project a little bit more and see what comes from that.
Okay. Let me know if you have questions as you work through it. So the rest of the class is until the final lecture, where we're going to put together some like advanced SQL, like using T-SQL and stored procedures, and you can create your own functions in a database too. It's the first time I'm going to teach this, but I left it out of all the other classes, but I felt as though it was kind of a part that was missing. It's kind of like an advanced feature. So we'll do SQL one more time there. But the other two are really, there's database design class, which we work more, and that's more diagramming and not code. And then the last one is more about data in the enterprise and just a lecture on it. Not as much SQL as I can remember there either. So what was my point here? So no, for the project, mostly all the SQL coding you need to know is done now. The rest is like diagramming and putting together data dictionary and doing data quality and stuff like that. More taking database and taking the database knowledge that you have now and applying it to business intelligence and what you see in the data in the enterprise, how to design databases and stuff like that. I was going to look to see lecture 7. And talk about ETL, data governance, data quality. Yeah, not really any more code. So you could probably fly ahead with all of those examples. And if you have questions, let me know and we can work on the code the last couple of lectures. I moved that advanced one, like it's at the beginning of class, to class 8 because it's going to be a short lecture since it's the first time I put it together. So we have a good like 2-hour working session at the end of the class for whatever we want to cover. I might try to put some of this data in Power BI too. Show you what that looks like. Michael, still all right down there? I don't know why I always keep looking up while you're sitting down.
Yeah, I'm good here. I think I've so little movement that it freezes my frame.
All right, well, I guess that's probably it for tonight. I'd be happy to hang out a few more minutes.
I think I'm good. I appreciate your help in getting me that desktop version so I can get that permission and try that.
If you have problems installing, let me know. Ronnie, do you have a Windows computer?
Yep.
The instructions are tailored since all my machines are Windows. They're mostly tailored for that. So you shouldn't have too many problems, but let me know if you do. It seems usually there aren't too many problems. It's just small little things with each operating system, just a small difference. that I can't even recall right now, but
Mm-hmm.
I always remember it when I come across it.
And I may ask for a separate surface that I can have off the domain, just so if I need to, install or do something during class, be working in the cloud environment that you have set up, but then have that second device that
Yeah.
I don't have to be too cautious of memory issues or anything, do I?
No, I don't think so. As long as if you have a decently powered laptop, you could run SQL Server on there pretty easily.
Mm-hmm.
Shouldn't be a problem. It's meant to be kind of lightweight.
Okay. But
Concerning
a
other.
Surface Book is all right. A Surface, you think I could do it on, or I got to make sure it's a laptop?
Surface has Windows operating system, right?
Right. Yep. Yeah.
Yeah, you could if you're comfortable with that, you could give it a try. I've never done it, but
Well, I might try that just to have a machine where I can get around the domain and just, if I have to install something or have to tweak something, I'm not worried about messing on the domain.
Let me see. Yeah, I'm sure these are almost any computer nowadays is more than well enough power and powerful enough to do it.
Right.
This would be more than enough.
Okay. All right. Well, I'm going to call it a night and get a couple other things done here.
All right.
Okay. Thanks much.
Yeah, no problem.
Good night, everyone.
Have a good night, everyone.
Good night.
Bye.
Right. See you, Ronnie.
See ya.
Bye.
See ya.
All right, I'm just bringing this to a close. All right, that is it for class 5, cleaning data. The next class, we will visit some data architecture and database design principles in structuring and modeling data. That will be class 6. And until next time, I'm Jeremy Bergman, and I will see you next time. See you on Wednesday. Thanks. Bye.